You've probably heard the saying, you are what you eat, but have you ever heard, you are what your parents ate? When we make choices like whether to eat an apple or slice of pizza, we usually don't think of how it impacts our future generations.
But it turns out that such consequences are quite possible. Welcome to Epigenetics.
Epigenetics is a study of heritable changes in gene expression that don't alter the DNA sequence itself. In addition to a genome, we also have an epigenome, which is a set of chemical tags that tell cells how to read DNA. Your epigenetic tags can be affected directly through your health habits and exposure to toxins, or indirectly through stress or social situations. Think of the genome as computer hardware, and the epigenome as software. Like software, the epigenome can change, so if you start exercising regularly, you can download a tag for a faster metabolism. There are three main ways your epigenome can be modified. First, histone modification. Your DNA is organized by wrapping itself around proteins called histones. By attaching epigenetic tags like acetyl, methyl, or phosphate groups to histone tails, we can change how tightly DNA is wrapped, like turning a spool. Our gene we want to be expressed is in the thread of DNA. If the DNA is wrapped loosely, the gene can be read and expressed. If wrapped tightly, the gene can't be read. DNA methylation. DNA is transcribed into messenger RNA through RNA polymerase, and messenger RNA is translated into proteins in ribosomes. But transcription can't happen when the promoter is blocked by methyl groups that attach to cytosine nucleotides. RNA polymerase cannot bind, so the gene is not expressed. Think of it as an off switch. MicroRNA. Once upon a time, little Meg, the mRNA, was just finished with transcription. On her journey from the nucleus to her ribosome, Mike, the microRNA, pulled up in a white van and offered Meg some candy. Meg, being born just a minute ago, naively accepted and bonded with Mike. Meg was never seen again, and her gene sequence was never expressed.
That's how that works.
Why should I care?
Well, inquisitive but grumpy me, it matters because your epigenome can be changed during your lifetime, but also parts of it can be passed on to your posterity.
Think of them as sticky notes. When an embryo is formed, life takes the parent epigenome, shakes things up a bit, and passes the extra sticky tags on.
Epigenetic inheritance has revolutionized the way we view the nature-nurture issue, evolution, and medicine. Scientists are now looking to epigenetics to turn off genes that play roles in dormant diseases such as cancer, Alzheimer's, and diabetes. Lastly, while choosing pizza over an apple once in a while probably will impact your future generations, things like doing drugs or not exercising can definitely change your epigenome for the worse. So stay healthy, my friends, for the sake of epigenetics.